Alright guys, today we are doing a section called Graphs of Functions and Equations. And we have a few examples of what we're trying to do here. You can see we're going to be graphing some things here. And so let's see what they ask us here. The distance that Giselle can run is a function of the amount of time she spends running. Giselle runs 3 miles in 21 minutes. So assume she runs at a constant rate, okay? And there's a few important things here. First of all, they tell us this is a function, all right? So that tells me whatever input I put in, I'm only going to get one output that matches that, okay? And also, assume that she runs at a constant rate. That is really important as well, because that is going to allow us to create an equation. All right, so the first part here says write an equation in two variables that represents her distance run. That's going to be our variable y as a function of the time, which is going to be x. All right, and since we know it's a constant rate, we can use y equals mx plus b like we have been for quite a while now. All right, and remember the m stands for your slope. And we said when you have a constant rate, you can really think of your constant rate as being your slope. All right, so I'm going to put rate right under here. And B is your y-intercept. And your y-intercept is the value of when x equals 0, what is your y value? All right, and that is your y-intercept. So I'll put a little question mark there by y. All right, so that'll allow us to make an equation that describes the situation. Okay, so let's try to do it here. Y equals, and what is my constant rate? Well, my constant rate is right there. All right, 3 miles in 21 minutes. So we always put the time on the bottom. So that's going to be 3 over 21. And my x is still going to be there. Now, what is my y-intercept? What if I plug in a 0 when I'm looking for my y-intercept? I plug in a 0, and that would represent 0 minutes. Well, if she ran for 0 minutes, well, wouldn't her distance then still be 0? Her y would be 0. So actually, the y-intercept in this case is a 0. Okay. So let's reduce some things. Let's make this equation a little easier here. 3/21 will reduce to 1/7. And I don't really need to write that x, or sorry, that y-intercept. So there's my equation that I'm going to use to describe this situation here. Okay. And the beautiful thing about functions is once you have that function, once you have that equation, it will then work throughout the whole problem here. We just have to plug in what they give us. It says over here, use the equation to determine how many miles Giselle can run in 14 minutes. Well, I have to make sure I plug it into the right variable. So up here it says y is the distance and x is the time. All right, so that would be where I'd want to put the 14 minutes. All right, so we're going to do that right here. Y equals 1/7, and I'm going to plug a 14 in for the x. Now I just there's really no algebra to do over here either. Is everything's on one side, so we just do the math, and we get, let's see, 14 times 1/7. That's going to be 2. All right. Now later on they ask us to write this as a point. All right, and my x value here is 14. I'm going to write that. I'm going to put that in a different color here. My x value is 14. And my y value is 2. So there's one of the points that I'm going to eventually graph over here. All right. So now let's do the others. Again, I'm using the same equation. How many miles can Giselle run in 28 minutes? All right. So I'm going to do the same thing. I'm going to plug in a 28 in where I see the x. And I'm going to do the math. Let's see. 28 times 1/7. That gives me a 4. So my point is going to be 28, comma 4. All right, so now I'm getting some points that I can graph eventually over here. All right, and one more. I want to know how many miles can Giselle run in 7 minutes, so I'm going to use my equation again. and I'm going to put in a 7. Okay, and for the x, and that's going to give me 1. All right, so again, that is going to give me a point of 7 comma 1. All right, so now I have these points that I can graph. All right, over on my graph over here. Now I want to look ahead here. I believe it is 20 spaces this way across the x-axis, and I believe it's 12 blocks up the y-axis. So I have to look ahead and I see, well, what's the biggest value I have for x? I have 28. All right, so I'm not going to go by ones here. All right, I'm going to go by twos. Okay, when I make my graph, so I'm going to mark these every other block. I'm going to say this is 4, and this one's going to be 8. And we're just going to go by 4s here so that every block represents 2. That's 16, and that's 20, 24, 28, 32, 36, and 40. Okay, that should give me plenty of room on the x-axis. And on the y-axis, now look, we only go up to 4. That's the highest y value. So it would be kind of silly for me to go by ones here because my whole graph would stop right here. So I'm going to go, let's say every other block is 1. So that's going to be 1. That's going to be 2. That's going to be 3. And that's going to be 4 up there. At least that gets me about 3/4 of the way up the graph here. So that's going to spread my line out a little more. And then I'm just going to graph these points, and I'm going to do my best to connect them with a line here. So 14 comma 2, that's right there. 28 comma 4 is way over here, and I need to go up to 4. So right there. Okay, and what do we got? One more. 7 comma 1 is going to be, actually that's going to be in between, right? That's going to be in between 6 and 8 comma 1, and it looks like they're going to line up. Now I also said my y-intercept is 0. So I could put that point on there too. She runs 0 minutes. She's going to go 0 miles. Now I'm going to do my best to line these up. That's a big jump right there. All right, and there we go. There's my line. All right. So we also have some other questions here. It says, what shape does the graph of the points appear to take? Now that's pretty easy. It's the shape of a line. Okay. And another question is, it says, is the function continuous or discrete? All right. And that's where we ask ourselves, can I plug in different values for x? Is there any limitation on plugging in values for x? Well, what is x representing? It's representing the time. And so could I plug in like 9.6 seconds? You know, could you plug that in, and would that make sense, the answer that they give you? Sure. You can plug in a decimal amount of seconds, all right? And you can plug in pretty much any amount of seconds. It can be any decimal that it wants. So I'm going to say that this is a continuous, all right? That's a continuous function, okay? And it also says, assume that you use the rule that describes the function to determine how many miles Giselle can run for any given time, and wrote each answer as an ordered pair. Well, where do you think that these points would appear on the graph? Okay, well, since this graph represents this equation right here, okay, any point that I plug in for time, any time that I plug in here is going to give a matching y, and they're all going to be on this line. They're all going to be dots. Am I in blue? Let me get me in blue here. They're going to be dots all along this line. So any value of x that I plug in, that's supposed to be on the line, any value of x that I plug in, and I get a matching y, if I were to graph those, they're going to be on this line. And this, in fact, this line represents all of the solutions, right? All of the ordered pairs that represent solutions for this line. All right, so there you have it. There's exercise 1. Let me clear the deck here, and we'll go on to exercise 2. Okay, here is exercise 2, and this is very similar to exercise 1, so if you got that one, this shouldn't be too much of a jump for you here. It says the number of devices a particular manufacturing company can produce is a function of the number of hours spent making these devices. On average, 4 devices are produced each hour. Okay, so I'm going to underline that part right there because I know that that is my rate. Okay, that is my rate right there. So I'm going to go ahead and put that right over here. 4 devices per hour, and that's really kind of neat because I can just write it as a 4, right? So assume that these devices are produced at a constant rate. Okay, so that's good. Just like last time, it says write each equation in 2 variables that represent the number of devices y as a function of the time the company spends making the devices. All right, so since it's a constant rate and we want a 2-variable equation, it all comes back to y equals mx plus b yet again. All right, so if we plug in the slope of 4, we get y equals, oh, that's a really bad y. Let's make that one a little bit better. All right, y equals 4x. Now, what's going to be my y-intercept? Well, again, if you think about it, if we spend 0 time making these devices, meaning x is going to be 0, right? If I plug in a 0 for x, well, I haven't made any devices if I spend no time making those devices. So my y-intercept again is going to be 0. So really what I'm saying is right here's our equation. Okay? Now if I were going to say, "Oh, wait a minute, we started with 50 devices already made," then I'd put a plus 50 there, right? Because we're starting at time 0, we're starting with 50 devices, but we haven't made any. So right here, this is our equation that will work for us, okay? All right, so now once we have the equation, once we have the function, all right, the rest is really super easy, okay? Because you simply yeah, I can't talk today. You simply plug in the numbers that they give you. You got to make sure you put it in the right spot. So how many devices are produced in 8 hours? Well, which of these variables is describing time? All right, and right here it says the time is going to be your x. So I'm just going to come over here and I'm going to go y equals 4, and I'm going to plug in an 8 where I see the x. Well, 4 times 8 is 32. All right, and just like I did before, I know this is coming up next, so I'm going to put this as an ordered pair. All right, that is going to be 8, comma 32. Okay, there's my ordered pair that I make out of this information. Okay, so how many devices are produced in 6 hours? Well, I use the same equation and I plug in a 6. All right, so 4 times 6 is 24. And again, I'm going to make an ordered pair out of that. That's going to be 6, comma 24. All right. And the third one here, how many devices are produced in 4 hours? Well, again, I plug in a 4 times 4. I plug in a 4 for the x, and I get 16. Okay, and my ordered pair there is going to be 4, comma 16. Okay, and what we want to do, we already did this part. We want to graph this information. Looking down the x values here, the largest one I have is 8. So I think I'm just going to go by ones, all right, along here. That's going to get me out. Well, actually, you know what? I can go by every other block is 1, all right, and that's going to spread my graph out even more. All right, I'm going to make that 5, that a 6, that a 7, because I want to use the whole piece of graph paper if I can. That's going to make my graph look a little better. Yeah, that's much better. Okay, if we go across like that. And then looking down the y values, the highest one here is 32, and I believe I have 12 blocks here, so I can't go by ones, I can't go by twos. I think if I make every block 4, all right, that's going to get me up high enough. So I'm going to say this one is 8. Okay, I'll make a little better 8 there. All right, this one's going to be 8. This one's going to be 16. This one's going to be 24. All right, this one right here, that's going to be my 32. And that one's going to be 40. So that gets me up to where I need to go. All right, and then just go ahead and graph them. All right, I'm going to go ahead and graph them. 8 comma 32, that's way out here, and I'm going to go up to 32. That's going to be a dot right there. And let's see, 6 comma 24 is going to be here. That's going to be right there. And what else we got? 4 comma 16. 4 comma 16 is right there. Okay. And I can do my best. Of course, 0, 0. That's my if my y-intercept is 0, that point still works. So now I've got to try to line these up. That does not look like a good start here. I got to try to line these up just like that. All right, so there's my graph. It does say, is this a continuous function or a discrete function? I couldn't quite fit it on here, but your packet does say, is this a function of a continuous function or discrete? And again, we have to determine along the x values, can I plug in uh, can I plug in anything that is non decimal like or non-fraction like, or is there any kind of limitations here? Not really. Okay, not really, because I can plug in 3.3 minutes. Okay, and I can plug in 7.8 minutes, etc. All right, so I'm going to again say that that's a continuous. All right, that is a continuous function. Okay. And then there is there another little section here? No, that's it. That's it. All right. As far as this question goes, so we've done all that. I do want to do the other two examples. These don't take really too long at all. Let me just wipe these off and put in number 3 here. Now, number 3, this is something a little different. Are the following graphs functions or not functions? And here's the thing. We've always worked with equations, all right, to determine whether you have a function or not. But here's the neat little thing. If you have the graph, right, we have this thing called, or I shouldn't say this thing, we have this theorem, all right, use our math terms here. We have this theorem, okay. I shouldn't even say vertical theorem, all right. We don't call it vertical theorem. It's called the vertical line test, all right. And the vertical line test is a very, very simple way to see if you have a function or not directly from a graph. All right, and here's all you do. You imagine you're taking this graph. You imagine putting as many vertical lines on this graph as possible. All right, so I could put a vertical line right down the y-axis like that, and I could put a vertical line right down here, and I could put a vertical line right down there. And I imagine I'm putting so many vertical lines on here, and what I want to test for is, uh, does any of these vertical lines go through more than one point on my graph? Okay, because that really is a graphical way of thinking, do any of my inputs yield more than one outputs, like we did, a few sections ago. And look right here, I'm going to circle them. Right here, look at this vertical line goes through 2 points. As soon as that happens, that tells you that this is not a function, okay? Because it fails the vertical line test. How easy is that? All right. So the vertical line test is a great thing. Once you get the graph on there, then you just throw a bunch of vertical lines on there, and you don't even have to write them in like I did. If you can do it mentally, even better. As soon as you see 2 points that are going to be intercepted by these vertical lines, one vertical line, then you know it's not a function. Okay, let me take that one off here and let's put this one on here. Think of the same thing here. All right, think of putting a bunch of vertical lines down through this graph. I know mine are not very straight because I'm trying to do this freehand here, but look at, are there any 2 points that are going to be intercepted, okay, by one of these vertical lines? And it doesn't look like there is. All right, it doesn't look like there is at all. All right, these points would have to line up, and I don't see any points that line up on those vertical lines. All right, so vertical lines test says yes. All right, this function, this passes. Whoa, what happened there? Okay, I want to do that. This passes the vertical line test. So that tells me that yes, it is a function. All right, this is a function. Okay, so super easy to do the vertical line test there. All right, so that's all I got for you. The first two exercises were a little more involved. Obviously, you had to come up with the equation, and then you had to plug some numbers in, then you had to graph it. All right, but this vertical line test is really super easy. So hopefully you get that. So thanks for watching. Enjoy your night. We'll see you tomorrow.